Today, seniors, this video lesson we will answer 3 problems that are very much similar to what you will encounter in your homework number 3, problems regarding geometric progressions. Let's begin. What number must be added to each of the numbers 4, 10, and 14 so that the resulting numbers form a geometric sequence? So you don't know what you should add to 4, to 10, to 14. So just let that number be x. So this would be x plus 4, x plus 10, and x plus 14. If these 3 terms are to form a geometric sequence, then this must have a common ratio. So when you divide the second term by the first term, it should be equal to when you divide the third term by the second term. So solving this equation, you get x plus 10 squared equal to x plus 4 times x plus 14. So this would be x squared plus 20x plus 100 equal to x squared plus 18x plus 56. So x squared will cancel out. Then 2x is equal to 56 minus 100, or negative 44. Then x is equal to negative 22. The next problem. In a geometric sequence, whose first 3 terms are 384, 288, 216, which term is 729 over 8? Obviously, this is our first term, 3 and 384. Then we can get also the common ratio. We can divide, simply dividing the second term by the first term, 384. Now, when you're dealing with large numbers, it's very convenient if you will express your large numbers into prime factored form. Now let's have so we can have enough time to answer. I'll just use this Casio ClassWiz calculator emulator. So this is the actual, this is how your calculator will look like. So simplifying 288 or 384, oh, that's 3/4. So you see how easy that is? Yes, 3/4. So we have the first term, we have the common ratio 3/4. We're asked which term is 729 over 8. So remember, the formula to get the n term is equal to a sub 1, the first term, times common ratio raised to n minus 1. Now we have 729 over 8 equal to a sub 1, that will be our 384, multiplied by the common ratio 3/4 raised to n minus 1. We are actually solving for n in this equation. Now again, just like what I said, it's easier if you have your large numbers into prime factored form. So I know you know how to do that using your factorization. Let's have, again, let's just use the calculator here. 729. Okay, 729 into its factored form. That's actually 3 to the 6. So 3 to the 6. Now let's have, this is 3 to the 6 over, of course, 8. We know it's 2 cubed. 384. In this equation, we will divide both sides by, or multiply both sides by 1 over 384, so both sides. So dividing it both sides by this, we'll have this term cancelled, this number cancelled, giving us with 3 over 4 to the n minus 1 isolated. So that will be 3 over 4 to the n minus 1. Now, if we're dividing 384, that means 384 will be in the denominator, so it will be here, times 384. Again, it's prime factor 384. That's 2 to the 7 times 3. So that's 2 to the 7 times 3. Now, this would be 3 to the 6 in the numerator over 3. That will be 3 to the 5th. And then 2 cubed and 2 over 7, that's actually 2 to the 10. But of course, 2 to the 10 is the same as 4. So this is 3 to the 5th. And if 2 to the 10 can be written as 2 squared raised to the 5th power, or simply 4 to the 5th power. So 3 to the n minus 1 in this equation, look at this equation. 3 over 4 to the n minus 1 is actually 3 over 4 raised to the 5th power. Since 3 to the 5th over 4 to the 5th is quantity 3/4 to the 5th. So that makes clearly n minus 1 equal to 5. Then n is equal to 6. So the answer to this problem, the 729 over 8, is actually the 6th term of the geometric sequence. Let's move to the next. The 5th term of the geometric sequence is 32. So that means a sub 5 of our sequence, 32. The 9th term, so our a sub 9, the 9th term, 512 over 2401. What is the 3rd term of the sequence? So we're asked the 3rd term. Okay, now again, your a sub 5, that can be written as a sub 1 times r, common ratio, raised to 4, and that's equal to 32. We can have this into prime factor, 2 to the 5th. Now a sub 9 can be written as a sub 1 times r to the n minus 1. That will be 8, 9 minus 1, and it's equal to 512 over 2401. Again, large numbers. You have here 5112 into its prime factor. Just shift and then factor 2 to the 9, 2401. Is 7 to the 4th. Okay, now here we have this and this. So when we divide a1r to the 8th over a1r to the 4th, that will be equal to quantity 2 to the 9 over 7 to the 4th all over 2 to the 5th. So if we simplify this, notice that the numerator 2 to the 9 of in the numerator, and you have the 2 to the 5th here. So this can be written as 2 to the 9 over 7 to the 4th times 2 to the 5th. So this would be 2 to the 9 over 2 to the 5th would be 2 to the 4th over 7 to the 4th. So this would be equal to simply quantity 2 over 7 to the 4th power. So we have here the left side, a sub 1 will cancel out, r to the 8 over r to the 4 will be of course r to the 4th, and it's actually equal to 2 over 7 all raised to the 4th power. That means your common ratio is 2 over 7. Now using this, let's erase some of our solutions first. Now we have the common ratio. We use that to solve for the first term. So since the 5th term a sub 5 is equal to a sub 1 times the common ratio to the 4th, and it's equal to 32. Then the first term is simply 32 divided by the common ratio raised to the 4th power, or simply 2 over 7 raised to the 4th power. And okay, so let's simplify. So the good thing about calculators which are in natural displays, that you can just write the expression as is in same syntax. So you have here 32 all over the quantity 2 over 7 and then raised to the fourth power. So the first term is 4,802. Let's check that. 4,802. So since we have the first term 4,802 and we have the common ratio, we can get any term. In this case, we are asked the third term. So the third term is simply the first term times r to the n minus 1, or r2, r squared. So it's equal to 4,802 times 2 over 7 raised to the second power. So again, just use this. 4,802 times the quantity over 7 and then squared. So the third term, our answer would be 392. Okay, so let's move to my favorite part. The best way to learn is to do it yourself. Here are 3 problems very similar to what I just answered. So I hope you answered these 3 problems for practice. Good day, seniors.